So next problem will be on the basis of how to relate equation of motion. So for equation of motion, we just use v equals to u plus a times t, in which each term will be relativistic and with the same reference. Suppose if you have to calculate final velocity of a with respect to b, so initial velocity of a with respect to b also, and it will be acceleration of a with respect to b also. And I defined in last class, time will be always non-relativistic. Time will be relativistic only in case of speed of object will be very large as compared to speed of light. Similarly, for displacement between any two body, it will be uab times t plus half of acceleration times t squared. Let me define you a question related to this. There is a question in NCERT on a two-lane road. On two-lane road, car A is going along east at 36 km/h. Two cars, B and C, moving in opposite direction at velocity 54 km/h. If at separation between AB, AC equals to 1 km, driver of car B decided to overtake A before C crosses it. Then find minimum acceleration of car B to do so. If in doubt,
No, sir, fine.
let me define you how to solve this. Suppose this is your two-lane road on which a car is going along east at 36 km/h. Suppose on first lane. So this is car A going along this direction at 36 km/h. So if you multiply it by 5/18, it will be 10 meters per second. Two cars, C and B, moving in opposite direction at 54 km/h. So if you multiply it by 5/18, it will be 15 meters per second. Let's say B, and 15 meters per second, let's say C. At this instant, when separation between AC and AB is 1 kilometer. So driver of car B decided to overtake car A before C crosses it. So how to start with it? First, try to find in what time car A and C will cross each other. So let's start with A and C part first. For A and C, velocity of A with respect to ground is towards positive x-axis, so it will be plus of 10 meter per second. Velocity of C with respect to ground is along west direction, so it will be negative 15 meter per second. So if you have to relate these two terms, velocity of A with respect to C, first try to calculate this part. You have given displacement between A and C is 1 kilometer. So displacement of A with respect to C is 1 kilometer, which will be 1000 meter. And there is no acceleration between A and C. So acceleration between AC will be 0. If you put these values in second equation of motion, you will get time in which A and C will cross each other. Is it clear?
Yes, sir. Sorry.
Okay. Good, Ifra. Just put this value in second equation of motion and try to find time. Good, Ifra. So now for A and B, velocity of B with respect to ground is along positive x-axis, so it will be plus 15 meter per second. And velocity of A with respect to ground, we have calculated as plus 10 meter per second. So first, velocity of B with respect to A, first find this. This will act as initial velocity between A and B. Displacement of B with respect to A is also 1000 meter. And since only B is accelerating, A is moving with constant velocity, so its acceleration will be 0. So there will be acceleration of B with respect to A equals to B with respect to ground and A with respect to ground. Since this term is 0, so you're left with just this part only. Put the value of time to be 40 seconds as duration of time in which B has to cross A is just 40 seconds. So put all the values in second equation of motion, then you will get the value of acceleration of B with respect to ground. Is it clear, Ifra?
Yes, sir.
Try to solve. Ifra, since both objects are going along same direction, velocity of each object will be in positive. So velocity of B with respect to A will be just 5 meter per second. Ifra?
Yes, sir. I got confused.
Displacement of B with respect to A equals to initial velocity of B with respect to A into T plus half of acceleration of B with respect to A into T square. Just put all the values and try to find this acceleration. Just see this. We have displacement as 1000. Initial velocity is 5, time is 40, plus half acceleration of b with respect to a is also equals to b with respect to ground, and time is 40 squared. So this 2 and this 40 will cancel out in 20 times. So this will be 1000. 5 into 4, 200, plus 20 into 4, it will be 800 acceleration of b with respect to ground. So if you move this down to left side, it will be 800 equals to 800 times this. So acceleration of b with respect to ground will be just 1 meter per second squared.
Yes, sir. I have written 800 as safety by mistake.
Okay, okay.
Done, sir.
Okay. Similarly, there will be a question related to vertical motion or in terms of gravity. So let me define your problem how to relate. Suppose you have a building like this. From ground, a body is projected upward, and from top surface at the same instant, another ball is dropped in downward direction. Let's say velocity of this particular object is 25 meters per second. Total displacement from ground to this initially is 100 meters. So you'll be asked to find time of meeting and position of meeting. For two different bodies. So let me start with this part. Let's say this is A. So for A, take this particular point of thrown off body to be origin and define each term with respect to this part to be origin. So velocity of A with respect to ground is 0. Acceleration of A with respect to ground is along downward direction, so it will be minus g. And displacement of A with respect to ground is 100 meter. Is it clear?
Yes.
Similarly, let's say this particular object to be B. So velocity of B with respect to ground, since it is projected upwards, so it will be plus of 25 meter per second. Acceleration of B with respect to ground is also minus g, and displacement of B with respect to ground is just 0 since it is at the ground initially. Now we have to relate these two terms. So on going from B to A or on going from A to B, we may go either way. So first, velocity of B with respect to A, just try to calculate. Acceleration of B with respect to A, and then put all the values in second equation of motion, you will get time. Is it clear?
Yes, sir.
Try to simplify it. Since displacement of A with respect to ground is along downward direction, which will be in negative y-axis, so it will be just minus 100 meter. Now, try to find initial velocity, initial acceleration, and initial displacement with respect to E. And then put all the values in second equation of motion. You will get time. Good, Ifra. Good, Ifra. Good, Ifra. So you have calculated time to cross A and B will be just 4 seconds. So now if you take individual object and you may find displacement of each term individually so that you may define position at which the two will cross each other. Let's say for A, y equals to ut minus half g t square, and t is just 4. So it will be 4 into 4, 16, divide by 2, 8 into 10. So it will be just 80 meter. It means at this point, that will be 20 meter above the ground and 80 meter from this point, two balls will cross each other like this. Is it clear?
Yes, sir.
Okay. You have written?
Yes, sir.
So this is all about one-dimensional relative motion. Next is how to deal with two-dimensional relative motion. Let me define the first case and the most important part about the river problem. Suppose there is a river whose width is W, which is flowing towards east at some velocity u. Let's say this is vertical line. So a swimmer who can swim in still water at some velocity v dives into it at some inclination theta with velocity v. So on the base of this theta, there will be two different components of this velocity. So one will be along this direction, that is v times cos theta, and the other will be along this direction, that is v times sine theta. In this case, I've just considered a river having width W is flowing towards east at velocity u. A swimmer dives into it at velocity v at angle theta. So you may define some of the term. First is velocity of river with respect to ground is along positive x-axis, so it will be u times I cap. Velocity of swimmer with respect to river, since he has just dived into river, so river will be system for that particular swimmer. So velocity of swimmer with respect to river having two different components, so it will be minus of v cos theta I cap and plus of v sine theta j cap. Now, velocity of swimmer with respect to ground, we have to calculate. So it will be velocity of swimmer with respect to river and velocity of river with respect to ground. Since reference point of these two terms is reverse, so there will be positive sign in between. Ifra, is it clear?
Yes, sir.
So now, if you put all the values, velocity of swimmer with respect to ground is minus of v cos theta along I cap and plus of v sine theta along j cap, and velocity of river with respect to ground is just u I cap. So on rearranging, it will be u minus v cos theta times I cap and plus of v sine theta times j cap, like this. First, write it down to this part. Ifra, written?
Just 1 minute, sir. 2 lines are
Okay.
done, sir.
Now, in this expression, for velocity of swimmer with respect to ground, we have two different terms. First is u minus v cos theta along I cap, and second is v times sine theta along j cap. Since these two components will be in different direction, this is along x-axis and this is along y-axis. So y component will be responsible for crossing of river. So from this part, we can solve time to cross a river. So time is distance by speed. Width of river along vertical direction will be y, w, and velocity in that direction is just v sine theta. So this will be total time duration in this part. Now, to get this time to be minimum, this theta should be maximum and sine will be maximum at 90 degree. So for minimum time, which is also called normal stroke, theta will be just 90 degree. So if you put this term in above equation, you'll get T minimum equals to W by V, like this. Ifra, is it clear?
Yes, sir.
Now this horizontal component will be responsible to drift swimmer along a left side or along right side. It will depend upon the value of u and v cos theta. So you may define three different terms depending upon value of u and v cos theta. First will be if u is greater than v cos theta. It means stream of flow of river having velocity larger as compared to this v cos theta, so it will be responsible to drift swimmer towards right. So drift towards right. Next, if u equals to v cos theta, then these two terms will be equal in magnitude. So this whole component or x component of velocity will be 0. So this is called no drift. This is also defined as to reach just opposite end. So this will be condition to reach just opposite end, or you will say this is shortest path to cross river. So in this condition, if you calculate theta, it will be u divided by v, and time in this condition will be w by v times sine theta, or if you simplify it, you'll get w by root of v square minus q square. Ifra, is it clear?
Yes, sir.
So this will be the second case. Third, if u is smaller than v cos theta, then v cos theta will have more ability to shift or drift towards left. So it will be drift along left side. Now, the next problem is to calculate amount of drift. So drift is basically distance. So distance is equals to speed into time. So speed in that direction will be u minus v cos theta. And total duration of time for which this whole thing is moving is just t by v sine theta. So this will be the total amount of drift produced during this entire motion. Any doubt till this part?
No, sir.
So you mainly have to calculate only these things for this entire river problem term. First, write it down. I'm giving you a problem.
Okay. Done, sir.
A river 1 kilometer wide is flowing at 5 meters per second towards east. A swimmer who can swim in still water at 10 meters per second dives into it. Find first time to cross the river in normal stroke, angle of dive to cover shortest path, with respect to flow. Also find time to cross the river in this way. Just use the previous concept and try to find these terms.
Okay, sir.
You have done a little mistake. Since we have a river or width of river in terms of,
Okay, so yes, I haven't converted it. So,
check your calculation. We have width of river as 1000 meter. Velocity of flowing river is just 5 meter per second. And velocity of swimmer is 10 meter per second. You have to use only these values to find this term. Now apply the formula. Good, Ifra. You have to calculate angle with respect to flow of river. Find angle of dive with respect to flow. In this part, angle is respect to this particular horizontal line. But in this problem, I have just asked you to find this angle. Since this is the flow of river, so it will be 180 minus theta. Okay, Fra?
yes, sir.
Good, Ifra. Good, Ifra. Okay, so this is all about river problem. Next is there was a question in NEET 2016. This is east, west, north, south. There is a boat in a river which is going towards west at some 10 km/h. This is speed of A. There is another at distance of 100 km towards south, that is B, which is going along this direction at 10 km/h. Distance from this point to this point is 100 km. So you'll be asked to define in which direction A will observe B, or in which direction B will observe A. So for these type of problem, or how to approach these type of problem. So first, rewrite each term with respect to ground first. So velocity of A with respect to ground, since it is going towards west, so it will be minus of 10 km/h. Since also all of the quantity is in kilometer and km/h, so you don't have to convert in any other term. Next is velocity of B with respect to ground is towards north, so it will be plus of 10 km/h. Is it clear?
Yes, sir.
You may take this particular A along I cap and this B along J cap. Now, for A with respect to B, it will be VA minus of VB. So VA is minus 10 I cap and VB is minus of 10 J cap. Is it clear?
Yes, sir.
So if you want to calculate inclination as absorbed by this A, just calculate tan theta. It will be perpendicular by base. So perpendicular is minus 10 and base is minus 10. So it will be just 1. So theta will be 45 degree. And since both X and Y is in negative, so it must be along this direction, which is southwest. Is it clear?
Yes, sir.
So A will observe B is going along southwest direction at this much amount of velocity. Similarly, if you calculate for B, velocity of B with respect to A, it will be VB minus of VA. So it will be plus of 10I and plus of 10J. So it will be along this direction, which means northeast direction. Is it clear?
Yes, sir.
There will be a third problem related to this to calculate at what time separation between A and B will be shortest or minimum. So find shortest distance between them. So let me define you how to approach this part. Suppose at any instant t, this A has moved some distance along this direction west to reach at this point. So the total distance from this point to this point will be velocity into time. So it will be just 10 into t. Is it clear?
Yes, sir.
In that interval of time, B also has moved some of distance. So distance moved by B from this initial point, so it will be till this part 10 into t. So the total distance left out from origin will be this much, which will be equals to 100 minus 10 into t. It means A has moved to this point and B has moved to this point. So the total distance between A and B at this instant will be this part, that will be hypotenuse of this particular triangle. So distance AB will be equals to root under perpendicular squared plus base squared. So it will be 10t squared plus 100 minus 10t squared. So this will be total distance, that is S. And if you have to calculate shortest path, shortest or minimum, whenever you have to calculate minimum or maximum of a particular function, there is a concept of differentiation. So for any function to be maximum or minimum, differentiate it and put it to 0. Similarly, in this part, since we have to calculate shortest distance between A and B, so as S in this part is time-dependent function, so differentiate this with respect to time and put it to 0. You will get the value of time for which distance between A and B will be maximum. So you'll get T for which distance between A and B will be maximum. And then put the value of T in this above equation, you will get shortest distance between A and B. Ifra, is it clear?
Yes, sir.
Just try to solve this third part.
Okay, sir.
Any problem? Okay. S equals to 100t whole square plus whole square root under. You may write this particular term as power half, and you may expand this 100t square like this. Now apply the formula ds over dt. We have exponential, so it will be n x to the power n minus 1. This will be our first part. Differentiate each term individually, so it will be 200t plus 0 plus 200t minus 20,000 and equate it to 0. This term will be having negative exponential. So on multiplying with the right hand side with 0 will be 0. So you're left with just this part only. So 200, 200, it will be 400t equals to 20,000. So t will be 20,000 divided by 400. 20 and 20 will cancel out. So 50 hours. Now put this value in this above equation, you will get shortest distance between A and B. Ifra, is it clear?
Yes, sir, now it's
There will be only 30 at this point. Similarly, 30 at this point. Okay, Fra?
yes, sir. I'm just finding the shortest distance.
So if you put the value of time to be 5 hours in above equation, you will get S to be 50 root 2 kilometer. Okay, Fra?
Okay, sir.
Any doubt in this part?
No, sir. No, sir.
Okay. You have written?
Yes, sir.
Similarly, there is another concept related to rain problem. Suppose on a rainy day, this is east, north, west, and south, vertically up and vertically down. Rain is falling at some inclination theta with respect to vertical, for which there is two different components. Let's say this is velocity of rain with respect to ground along this direction, which may have inclination theta with respect to vertical, so that it will have a component along this direction, let's say B, and another along this direction, let's say A. A man holding an umbrella is going along east at some velocity u. So let's say a man with umbrella is going towards east at u on a rainy day. So velocity of man with respect to ground will be u times I cap. And velocity of rain with respect to ground will be a I cap and minus of b j cap, since b is along negative y-axis. So on the basis of these two terms, we may define velocity of rain with respect to man. So it will be ai minus bj minus of velocity of man. So on rearranging, it will be a minus u times I cap minus of b j cap, which means it will have two components. One is along x-axis and the other is along y-axis. So let's say this is y-axis and this is x-axis or east-west direction. So Ima should hold his umbrella in such a way like this. Umbrella. So that this inclination will be phi and this inclination will be phi. So if you calculate tan phi, it will be perpendicular. In this part, perpendicular will be x component. So it will be a minus u divided by base, that will be b, like this. So if a will be more as compared to u, inclination will be towards west. And if u will be more with respect to a, inclination will be towards east. And if a and u will be equal to each other, then there will be no inclination. He should keep his umbrella in vertical direction. Is it clear?
Yes, sir.
Okay, just write it down.
Done stuff.
So on the basis of this value may define different term. Let's say this is horizontal line, vertical for first case, so if A is greater than U, then phi will be positive. It means inclination will be towards left. So inclination will be like this. In second part, if A and U will be equal, so there will be no inclination. So it will be moved like this. And third part, if A is less than U, or if A is 0, so it will be like this. So in first case, umbrella should be like this. In second case, it should be like this. And third case, it should be like this. So if A is greater than U, phi will be positive, or inclination of umbrella is towards west. In second case, if A equals to U, so it will be no inclination, or phi will be 0. In third part, if A is less than U or A equals to 0. In both cases, it will move towards west. So inclination would be towards west, towards east. So on the basis of this part, there is a question in CRT. A man or a woman having umbrella is going on a rainy day towards east at 12 meters per second. And rain is falling vertically at 35 meters per second. So there is no any component of rain horizontally. So A will be 0. Velocity of man is given, that is 20 meters per 12 meters per second. And vertical component of rain, that is B, is given. So we'll calculate tan phi equals to U by B. Is it clear, Ifra?
Yes, sir. Sir, can you please write the things on the board? Just one.
Okay, just 1 minute. A man with umbrella is going towards east at 12 meters per second. If rain is falling vertically at 35 meters per second, find inclination of umbrella should hold in order to save himself. So in this part, we only have two components. One is velocity of man, that is U. And next is vertical component of rain, that is B. So A in this part is 0. So this would be the case of third. So umbrella should hold along or towards west at some angle phi, for which tan phi will be equals to U by B. Ifra, is it clear?
Yes, yes, sir.
Written, Ifra?
Yes, sir.
Okay, so this is all about